Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello, everybody. Welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. Today's episode is part 3, where we're still doing box fill, but today we're going to change it up a little bit because we've already spent time in part 1 and part 2 dealing with calculating box fill, and this is dealing with conductors 6 gauge and smaller. We haven't progressed on yet to 314.28, where we're dealing with 4 AWE and larger for pull boxes, U-pulls, angle pulls, and all that kind of stuff. We're going to get there. But since we spent so much time filling a box and understanding the box and selecting the box and dealing with cubic inches and all that, it's now time to understand some of the codes that are related to the boxes. So we're going to try today to focus on, probably in these smaller sizes, what you're going to be dealing with the most, and that is cable assemblies. But it doesn't always just have to do with cable assemblies, because some of these things are still going to apply also to raceways and things like that. But we're going to try to focus on the cable portion of that in this episode, and we'll move on from there, because as we start getting to larger things like 4 AWG and larger, we're really going to be migrating more towards raceway applications. So this episode, we're going to deal with some general requirements that are having to do with installation and that have to do with securing cables to boxes and the different aspects, so that we get a better understanding of maybe one significant change that took place in 314.17 that we want to talk about. Wasn't much of a change. It was already covered in non-metallic boxes, but it's kind of been mirrored now for metal boxes because it made sense. But we're going to kind of keep it light on this topic, and we'll talk about all the things that we really should be thinking about when we're doing that installation and we're installing our cables. Because typically, in this aspect of it, we're dealing with 6 AWG and smaller. We want to kind of focus towards the cable aspect. Again, there's still aspects of abrasion. There's still other things that take place when it comes to raceways and pulling conductors. But because of all the topics related, we want to really talk about cables in this episode. So if you're a guy or gal that listened to this part 3 because you're like, man, I want to get into the raceway part of it, we're going to cover that later. When we talk about EMT and rigid and all that, here we're kind of talking about the low-hanging fruit about cables, because they're more volatile, obviously, than a raceway, which is offering some type of protection. An NMB, a UFB, an SE, things like that have just a sheathing, and the sheathing thickness can be anywhere from 30 mils up, depending. But usually for SE, it's 30 mils of thickness. And NMB, it's the same thing. The UFB is a little different. They're enveloped. Every conductor's enveloped, so it's a little bit thicker. That's why it's harder to strip, obviously. So we're going to talk a little bit about that, but we want to talk about securing and some of the aspects in the code. And so what we're going to be today is in 314.17 for the most part, and we'll kind of move down the code from there. Up front, we are in the 2017 National Electrical Code. This whole series is geared towards that. We are working on the 2020 as we speak, but nothing is written in stone yet. It's still a work in progress. We've already been through the public comment stage. We next move on to the voting stage, and then, of course, the NITMAMs, and then finally it's all ratified, and you'll see it probably in the 2020, and we're good to go, and hopefully your state will adopt it without amendments, hopefully. Okay, so let's kind of dig in a little bit. So in your code book, you want to be at 314.17, and what we're talking about now is, okay, so we've established pull boxes, we've established outlet boxes, junction boxes, all these type of things in episode 1 and 2 of this series. If you haven't listened to those, go back and listen to them. Now we're going to talk about the boxes themselves and the conductors that actually enter the box. Now they can be, in this case, we're going to talk about them possibly entering metal boxes or conduit bodies through things like the messenger supported wiring or open wiring, and we'll talk, we'll kind of give you those articles. We won't dig into those, but we'll give them to you. And we'll talk about the different options for entering a metal box or a conduit body with these other types of wiring methods. And then, of course, we're going to talk about the change that took place to add the requirement for non-metallic sheath cable into the metal boxes and conduit bodies. That kind of makes sense. It's the same thing that was in non-metallic boxes, so we added some new language. So we'll talk about that. And kind of wrap that up and try to talk about all these things. So we're going to be in 314.17, and we might migrate a little bit to a couple sections downstream before we get to the big topic of 314.28 when we're talking about U-pulls, angle pulls, because that can get a bit more complicated, especially when we're doing a podcast where I can't give you any visual. But I'll do my best, as always, to try to paint you the picture. Okay. So let's get started. We want to be at 314.17, and we're talking about the conductors now. While this is going to be associated with cables or these other types of wiring methods entering metal boxes or conduit bodies, the key focus here is we're trying to protect conductors. Okay? That's what you want to keep in mind. So the charging statement of 314.17 says conductors entering boxes, conduit bodies, or fittings. It says, conductors entering boxes, conduit bodies, or fittings shall be protected from abrasion and shall comply with 314.17 A through D. So we have an A, a B, and a C, and a D. A is going to talk about openings to be closed. We'll dig into that in a second. B is going to be dealing with metal boxes and conduit bodies. So this kind of gives you all the meat and potatoes when it comes to these conductors that are entering, whether they're coming from an open wiring type of system that's on insulators, or maybe you have some existing concealed knob and tube, how they get into those boxes, all the way down to non-metallic sheath cable that would be entering, okay? And it also will get into a little bit about raceways and aspects of that, but we'll just kind of stay with me. Now, C is dealing with the non-metallic boxes and conduit bodies that did not change from the 2014 code to the 17. So if you're already familiar with that, it gives you some good information on that. And we do have an exception there. We'll just kind of briefly touch on that. And then, of course, D, which is dealing with conductors that are 4 AWG and larger. And again, we are still talking about abrasion. So we'll kind of get some nuances when we talk about that. So we really want to cover 314.17. Believe it or not, it can be a very impactful section that a lot of people's jobs can be failed because there's a lot of things that you have to take place in here. And I teach apprentices and journeymen on their way to becoming masters that you can't miss the low-hanging fruit that's easy for an inspector or somebody to learn and then slam you for, because you really need to know the basics. And so we're going to cover the basics, okay? Now let's look at the very first one. This is item A, and it says openings to be closed. Now all of you probably are familiar, if you listen to our other series, that this kind of is going to mirror what's in 110.12a. Now 110.12a talks about closing openings. And so we have the same kind of thing here. I don't know how many times I go to a project, or even if I'm just walking in a store, and if you're kind of like me, every store you go to, or everything that you shop at, like the Costco's or Sam's Club, whatever you shop at, I'm always looking around at the electrical. I can't help it. Whether I'm seeing how neat somebody was, or what they did, or just to look. And I always see boxes with knockouts missing. And I'm thinking, well, if it's up 25 feet, nobody's going to poke something in it. I just think it's poor quality. And to be honest with you, there's people that want to get something done really quickly and get in and get out, and they don't care. And then there's people that really do care about their work. If somebody did an installation and they knocked out a knockout and ended up not using it, then that tells me they screwed up and had to do it another way, or they were using a box that was already on site. You need to plug that hole. And that's just professional workmanship. They might say, I ain't got time for that. It's in and out, all about the money. Well, you know what? Me and you are probably never going to get along, because I got into this trade because of the pride in doing everything right. And yes, doing it in accordance with the National Electrical Code, which some people don't always agree, it's a minimum safety standards, but it's the right thing to do. to maintain the minimum safety standard. Anything that I want to do over and above it is just bonus that makes me stand out over somebody else. But I've got to at least do the code. So when I do a job and I walk away from that and I leave something less than the minimum standard, I am not doing the profession any great service. Because there's people like me who will walk and look, and you that will look at these things and go, God, what kind of chinchy electrician did that? And I'm going to assume the electrician did it. Because this is a permitted job. This is hopefully a permitted project. I understand that homeowners do some wacky things, but I mean, when I'm in commercial and I'm dealing with knockouts and boxes, things like that, I'm pretty much thinking somebody just was lazy here. And you got to make it right. So at the end of the day, I'm all about treating our profession the way it needs to be. You don't have to agree with everything in the National Electrical Code, but we can agree that unless it's amended by your local jurisdiction or by the state, that it is the de facto minimum safety standard. If I get pulled into court, I can point back and say, Your Honor, I did the minimum safety. I did not see that I needed to do anything more than this, that this was enough to mitigate the hazard. And then I have a better chance of winning that fight. But when I go in and I do something and I walk away and I know that it's wrong, then I have a hard time defending it in court. So, is the NEC the most cost-effective and most inexpensive way to install something? Absolutely not. Just because it's a minimum safety standard does not mean that it's the cheapest way to do it. And you have to remember that. Sometimes it can be expensive to comply with the National Electrical Code. It just is what it is. And I'm all about mitigating liability. So, enough of that. I'm sorry. I went on that little tangent. I'm off of that now. Okay, so clamping. So A says openings to be closed. So openings through which conductors enter shall be closed in an approved manner. Now, when you look at 110.12a, that is a little bit broader, okay, than this. This one's really dealing with the openings to which conductors enter. So the knockouts or anything that you might knock out of these boxes, then they need to be closed, okay? I could have a conduit body that has multiple openings in it, and the ones that I'm not using, you got to make sure you plug them, all right? Those type of things. So the concept here is to make sure that we're closing all these openings. It's one, it just looks bad, and two, rodents could get in, or you never know what could get in there, or something could poke in there, or just what could happen, okay? It's just not worth it. You could have a bunch of pests get in there, and it causes the wiring to overheat at that termination because it can't dissipate heat. That's the whole concept of sizing boxes, to allow for heat dissipation and to make up terminations and not cramp the conductors in there. And who knows what's going to happen. But we know we have to close that opening. So that's the charge here in A, is to do that. They are inexpensive little plugs, folks. Just plug those openings. All right. So that's what you have to do with A. Now let's move on to B. Now B is dealing with the metal boxes and conduit bodies. So that is specifically what B is charged with dealing with. Now it says, and I'll kind of read it and then I'll explain each part of it so that you can better understand it. Remember, it's a podcast, so I'm really trying to paint you a mental picture. And that's what I'm known for, so I'm going to try to do that here as well. So first thing it says, where metal boxes or conduit bodies are installed, okay, so provided you use them, with messenger-supported wiring, open wiring on insulators, or concealed knob and tube wiring, the conductors shall enter through insulating bushings. Okay, so if you're using these methods and they transition into a metal box or conduit body, then they have to go through insulated bushings. But then it says, or if you're in a dry location, you can do that through flexible tubing extending from the last insulating support to not less than 1/4 of an inch inside the box and beyond any cable clamp. So you have the option to go through an insulated bushing. Maybe it's going into the end of a raceway, or it's going into the end of an conduit body, or it's transitioning from the knob and tube, or transitioning from open wiring on insulators. Incidentally, that does exist in the code. So you're saying what those are. If you want to know what those are, then you simply, remember you're in chapter 3, so you want to go down and look at Article 398, that deals with open wiring on insulators, to get a better understanding of that. If you want to know what the messenger supported type of system is, if you've never done that before, then that is Article 396. And of course, knob and tube, if it's existing, then you're working with that. I'd love to just rip all that out, but if you're working with that, then that's in 394 for an existing application. Then you have some rules there for concealed knob and tube. Okay, so all it's saying here, though, is if you're going to bring them from this wiring method into the box or into the conduit body, then it has to be through an insulated bushing. However, if you're in a dry location inside of a building that constitutes a dry location, then I can transition with the flexible tubing into these boxes. And I just have to remember that I have to carry that flexible tubing at least 1/4 inch inside the box, but also beyond the clamp. That "and" is so important, because people will say, well, I just bought it in 1/4 inch and that's done. But then they don't extend it beyond the clamp, and then the clamp clamps down and it ends up clamping down on these conductors. Remember, we're talking about conductors here. Just because we have the method to get it into the box through the flexible tubing, that has really no bearing on the fact that we also have to protect the conductors, and we have to protect them. If there's an internal clamp, then we're going to have to protect it that way as well to make sure it doesn't crimp down onto the conductors, right? All right, so that's the first part, okay? It is a long paragraph, but it kind of gives you the gist of what we're talking about for these type of wiring methods and how to transition into these metal boxes or conduit bodies. Okay, we got that. Next, it says, okay, and this is the part that was added for 2017. It says, where non-metallic cable sheathing or multi-conductor type UF cable is used. Okay, so non-metallic sheath cable, NMB, could be a 14.2, 12.2, 12.3, 14.2, 14.3. Any of those sizes that would be non-metallic that goes up to the size allowance would qualify here. And then it says, or multi-conductor type UF. Then we're talking about underground feeder and branch cable. And that is something that transitions from, let's say, an exterior location or a wet location or whatever. Any of these, when they enter the box, they have to extend again the same thing. That sheathing has to extend at least 1/4 inch inside the box. But then you have that little "and." It says "and beyond any cable clamp." So yes, I could extend 1/4 inch into that box, but if that 1/4 inch doesn't get me beyond that cable clamp, then I'm probably going to need more than 1/4 inch. So 1/4 inch is the minimum, and that might suffice. But you still have to get it beyond that clamp, because what we don't want to do is have it enter the box and then turn around and have that clamp be able to clamp down on it. Okay. Now, some of these boxes have internal clamps that are built into it, kind of like the plastic ones, where it's kind of a spring-loaded or tension-loaded. And you just have to make sure that you push it down, and you want to make sure, 1, you have at least 1/4 inch in there, and 2, it goes beyond the clamps. If you achieve both of those things, then you're good to go. I do see this many times not done right. And why this got added to the 2017 code is because this is a requirement for non-metallic boxes. But it even makes more sense to do this with the metal box. Obviously, to fault out or ground fault out or short out to the box creates a hazard. If something's not grounded right, then it can stay energized until somebody creates that ground path. So it can be a hazardous situation, so we want to make sure that we do that. And that way, once we get that done, then that metal box can be connected to that equipment grounded conductor. We can meet the connection requirements of 250.8, and we just could be all happy, and everything's good to go. Okay? So we want to make sure that we get in there and we don't want to damage those conductors. Okay? And that sheathing offers that cushion, if you will, to protect those conductors as it comes into the box. So that's what we're talking about here. So that's new for 2017, but it's not really new in what you should have been doing already, because we do it for non-metallic, so it should have just kicked in and said, you know what, it makes more sense to do it with the metal, so we should have been doing it. But now it's been put in the code, so we are good to go. Now, it goes on to say, except as provided in 300.15c, it says the wiring shall be firmly secured to the box or conduit body. Okay, what does that mean? It says except for provided in 300.15c. All right, so this allowance is just saying, you know what, I don't always need a box between, let's say, where cables may enter a conduit or tubing, whether it's for protection or maybe supporting that cable. Now, here's the funny thing. When I put that cable inside of the raceway, whether it's for support or for physical protection or from physical damage, you can't meet the securing and supporting requirements of the actual cable's articles. Like for a non-metallic sheath cable, you secure it and support it every 4.5 feet. Well, it's kind of already considered done when it's inside the conduit or the tubing. So, people get lost in that all the time. I'm like, how are you going to support it or secure it inside there? It's already being done by virtue of being in that system. So all this is saying you secure them to boxes, but there are some allowances where you're going to sleeve it for protection. And so you do it this way. Now, the other thing that this states is that in C, it does state where a fitting shall be provided at each end of the conduit or tubing to protect the cable from abrasion. So one classic example of this is when we take NMB and we sleeve it down, let's say a tubing, EMT, which is incidentally is a tubing, not a conduit, but they're both raceways. I have another episode for that, explains all the different wiring methods. But in this scenario is you're going to have to put the bushing on the top, and you might have to put a fitting on it with the bushing on it in order to protect from abrasion as it enters into that raceway, or in this case, yes, a raceway, but tubing, to protect that cable. But it doesn't necessarily mean that it has to be connected to the box when it gets down to the box, because there is no risk of abrasion at that point. Okay, because it's connected into a fitting that's connected to the box. And so where you typically are required to connect that cable to the box, this is an allowance where you don't have to physically connect it to the box. Okay, because it comes in. And it actually won't be there won't have any potential abrasion at that point as it enters into the box. Okay, all right. Now, a little different when you have a raceway and you have individual conductors, and they're 4 gauge and larger, then you're going to have potential abrasion as it comes to a raceway into the box. And we'll obviously cover that here shortly when we get to 314.17d, okay? So slow your horses there. We're going to get there. So I'm just trying to give you the allowances to say, look, can I take that NMB and then bring it into an EMT? Yes, I have to protect it as it enters the end, and then it comes down into the box, but then that cable does not have to be mechanically connected to the box because of the allowances here, okay? All right? And then, so that's just kind of, I'm giving you the full spectrum of what's going on with that, all right? All right, so let's get on back here to 314.17b. Now, in last paragraph, it says, where raceway or cables are installed with metal boxes or conduit bodies, the raceway or cable shall be secured to the box or conduit body. Now, again, typically that's what you're going to do. You're going to secure it to the cable. But if the cable is going through a raceway, then it's pretty darn hard to secure it to the box because it's running through the raceway. So that's kind of the whole point of talking about the applications of 300.15c. And of course, you have other aspects that allow you to do this throughout the code that we'll go in more detail in other episodes. Just remember that typically the general rule is you bring a cable to the box, you secure it to that box, okay? Because we're talking cables, okay? If you're sleeving it through a raceway, in order to get it into that box, then it's pretty hard for you to secure that cable to the box in that aspect of it. But you most certainly still will secure that raceway to the box, okay? Except for applications where we're simply sleeving it for physical damage protection or things like that. Kind of give you the kind of overall scope. Now let's move on to the non-metallic boxes and conduit bodies. Now this is 314.17c. No change for the 2017 code. Same language as here. It's going to mirror almost exactly what we just talked about for the metal boxes. A little more verbiage, but it's pretty close. So let me read it, and then we'll discuss anything if we need. If it gets repetitious, we'll just say it's the same thing as we just talked about. It says C, non-metallic boxes and conduit bodies. It says, non-metallic boxes and conduit bodies shall be suitable for the lowest temperature rated conductor entering the box. Okay, so 90-degree rated conductors, 90-degree rated boxes, okay, in minimum. Usually not an issue for you to worry about, but you have to take that into account. If I have a lower temperature rating of 60 degrees, for example, and that's the wiring I'm using, then I have to make sure that my box is rated, is suitable for at least to handle that lowest temperature rating conductor in there. Okay? It says where non-metallic and conduit bodies are used with messenger support wiring open wiring on insulators or concealed knob and tube. That's very similar to what we just talked about. It says the conductor shall enter the box through individual holes. Okay, so you'll have individual holes that enter into the box, individual knockouts. Now it says the tubing. Okay, the tubing shall extend from the last insulated support to not less than 1/4 of an inch inside the box and beyond any cable clamp. There's no change at all there. It says where non-metallic sheath cable or multi-conductor type UF cable is used. Now this is the language that was used, that was extracted and moved up into B for metal boxes. It's the same kind of language. It says the sheath shall extend not less than 1/4 of an inch inside the box and beyond any cable clamp. Okay. The last thing we want again is to extend it in the box and meet the 1/4 inch, but it doesn't move those individual conductors beyond the clamp, and they could be damaged in some way. And some of those, even the non-metallic built-in clamps, can put a lot of pressure down on those conductors. And the last thing we want is to have it put so much pressure down on it that it damages the conductors. In many cases, the equipment grounding conductor is located right there beside those conductors. Like N and B, it's located in the middle for like a 14-2 or 12-2 between the two conductors, circuit conductors. Okay? It says, in all instances, all permitted wiring methods shall be secured to the box. Okay, so in non-metallic one, we have to secure them to the box and what have you. And we're going to look at an exception here in a second. So we have to secure all the permitted wiring methods, ones that we just talked about, or whatever permitted wiring methods that can be used for non-metallic boxes or non-metallic conduit bodies. They have to be secured to the boxes. Now we have an exception. And the exception itself is going to deal with additional supporting or fastening, if you will, and it's going to deal with, it's just going to reiterate the securing of the cable as it enters into the box and all this kind of stuff. So we'll talk about the exception here in just a second. But what we want to do is I want to remind you of a rule that many people forget, and as an electrician, it drives me absolutely crazy. So we'll talk about the wire, but once we get into this box, and we've covered how we secure it and how we get in it and how much we have to extend the sheath in and pass the clamps and if there's a clamp, whatever, let's talk about the free conductor again. 300.14 says link the free conductor in outlet, junction, and switch points. People do not leave long enough conductors. In fact, they tend to leave circuit conductors, which are the black and the white, let's say in a 14-2. Those are your circuit conductors. The equipment grounding conductor is not the circuit conductor. It's the equipment grounding conductor or the safety conductor. So they tend to think that they can leave the black and the white, if you will, adequately in length, but then they cut that equipment ground off too short. What a nightmare trying to get that back in the box and make up that joint. That needs to be also the same free conductor. It is a conductor, all right? So it drives me absolutely crazy that people do that. So re-looking at 300.14, which is one of the most important aspects of the code when it comes to making sure that we have enough conductor to do our terminations. Drives me crazy when I go to a job and I barely got enough that I can't even pull those switches out. There's more than enough room in that box. If you fold them conductors back, you masters and journeymen need to teach your apprentice how to properly fold and lay and push these conductors all the way back in the back of the box. What I find out is when people pull things out, even when they're troubleshooting, and they're always scared because it's hot, and I'm like, turn the power off. Do your testing, turn it off, get those conductors put back in there nice and neatly done, and then turn your power. I don't know why. I see some of the craziest stuff, but leave me enough conductors. So what the code says in 300.14, it says, link the free conductor at outlet, junction, and switch points. At least 6 inches of free conductor. How do you measure it? From the point in the box where it emerges from the raceway or cable sheathing, which shall be left at each outlet, junction, and switch point for splicing or the connection of luminaire or devices. You got to give me enough to be able to get in. Okay? Now, I don't care if you have a multi-gang box and you want a daisy chain or you want a pigtail and have jumpers. I don't care. But don't try to give me 6 inches by a pigtail. I need to have free conductor at least 6 inches that enters into the box. Okay, and we're going to read this a little further because you need to understand that there's also another caveat to this. All right, so I need at least 6 inches as it measured from the point where they enter the box where it emerges from the raceway or the sheathing. Now, it also goes on to say where the opening of the outlet junction or switch box is less than 8 inches in any dimension. Now, I'm telling you right now, a normal nail-up box is going to meet those requirements, okay? I'm just saying. The normal nail-up box is not going to be greater than 8 inches in any dimension. It's just not going to be that way. It's either going to be 4 inches high, or it's going to be 2 1/8 wide, or 2.5 wide, or whatever it is. It ain't going to be that way. To be honest with you, a 2-gang nail-up is probably not going to be more than 8 inches in any dimension. So with that said, I need to have at least 6 inches coming out. Now, if I have the application, so look, now, where the opening of an outlet box is less than 8 inches in any dimension, then each conductor shall be long enough to extend at least 3 inches outside of the opening. Okay? So remember that. Where the opening of the outlet junction or switch box is less than 8 inches. Okay? So understand, let's kind of wrap what I said around because I kind of went on my little tirade. All of the nail-up boxes that you're single-gang nail-up boxes or 2-gang boxes you deal with, all of those are going to be less than 8 inches in any dimension. They are. So if that's the case, then I need to make sure that I have at least 3 inches that extends outside of the opening. Okay? So that is what you need to understand. So you're going to at least meet the 6 inches, and that's a requirement for any box to have at least 6 inches. But where I have that opening that is less than 8 inches in any dimension, which is probably 2-gang boxes, single-gang boxes, 3-gang boxes will probably push you to where we're going to have 6 inches from the point of entry, from the immersion, from the cable or raceway. But any of those smaller ones, I need to make sure that I have at least that. Okay? So, again, where the opening of an outlet junction or switch box is less than 8 inches in any dimension, each conductor shall be long enough to extend at least 3 inches outside the opening. So the general rule is I need 6 inches of free conductor from the point where it emerges, but I also have to make sure that I have at least 3 inches outside of the box. Okay? So, with most of these boxes in depth, the key is I want to make sure I have at least 6 inches of free conductor, but I also want to make sure that if it's 8 inches or less, that it extends out at least 3 inches outside of that opening so that I can effectively make all those switches up, okay, or those devices up or whatever, okay? Ultimately, what does this mean? I got to have at least 6 inches. If I can achieve that 6 inches will also give me the 3 inches outside the box, great. But the general rule is I got to have 6 inches, okay? All right, that was a lot of explanation for that, okay? Let's see here. Oh, okay. There's an exception that we're going to talk about. It says conductors that are not spliced or terminated at the outlet, junction, or switch point should not be required to comply with 300.14. Okay, so if you're not splicing them, they're not terminating there, okay, that type of thing, then I don't have to worry about this free conductor application. That's a raceway or something that's going through or what have you. If I got splices, then I'm going to have to need this free conductor application. But if they're not spliced or terminated at the outlet, okay, just passing through, then I don't have to meet this free conductor. Remember, we talked about box fill, though. If I have a 12-inch loop, then I'm going to cut it. Then that counts as 2 separate conductors entering the box. So I have to take that into account for box fill. Okay? But as far as the 6 inches in general, if they were just passing through, then I don't have to have the 6 inches of free conductor. Again, 2 different rules, 2 different applications, but just remember how that's doing it. Because we could have less than 12 inches because we could have a conductor that's just simply passing through. Okay? All right. So that's what I wanted just to reiterate 300.14. And the reason I got redundant on that is because probably as an inspector, I see this failed more than anything. They just don't give us 6 inches as a base. And I most certainly don't get 3 inches outside the box on those boxes that are 8 inches or less in any direction. Okay? That's probably one of the biggest violations that I get. Now let's talk about that exception. So there's an exception to C, and it says, here's the exception, and we'll discuss it. It goes, okay, what are we exceptioning? What does the exception apply to? Well, we know it applies to C, but what parts of C? So it says, okay, where a non-metallic sheath cable or multi-conductor type UF cable is used with single gang boxes. Okay, so this is your single nail-up boxes. It says that are not larger than the nominal size of 2 1/4 by 4 inches. Okay, so 4 inches usually high, 2 1/4 wide, mounted in walls or ceilings, and where the cable is fastened within 8 inches of the box measured along the sheath, and where the sheath extends through a cable knockout not less than 1/4 inch, because we had that requirement in the charging statement, or the actual code language. Securing the cable to the box shall not be required. Multiple cable entries shall be permitted in a single cable knockout opening. Okay, well, we got that's important because many of these nail-up boxes will allow you 2, but it's also, you got to know the manufacturer of that box because it might only allow 2 12s to enter the same knockout. You wouldn't want to try to jam a 10-2 and a 4 whatever, a 10-2, let's say, and a 12-3 in the same hole. Again, the manufacturer's going to drive that. The point is, it is allowing you to take multiple cables to it. But what's the rule here? All right, well, this is important because we're dealing with one aspect because we're non-metallic sheath cable. So let's tackle these one at a time. So this is a normal nail-up box, okay, 4 inch by 2 1/4, okay, just a normal nail-up that we might put up. It could be 18 cubic inches, 22 cubic inches, 20 cubic inch nail-up box, but these are dimensions. So it's not larger than this. If I'm mounting it in a wall in the ceiling, usually they just nail it up to the stud. Then usually they have little knockouts on it that you just push them and it pushes in and holds it. So you don't have to, many of them automatically mechanically hold the cable to the box. But there's a lot of these out there where you can just punch out the opening. It's a little tab. And so there's nothing really securing it there. If that's the case, then I have to make sure that my staple or clamp or whatever that's allowed in the securing and supporting of 334.30, for example, for non-metallic, then I have to have that staple within 8 inches. Could it be at 6 inches? Could it be at 4 inches? Could it be at 2 inches? Absolutely. And then I can go on and secure it the next 4.5 feet if I want. That's my normal 334.30. This is just saying if you have this plastic box and you're bringing in non-metallic sheath cable and you're not going to secure it to the box, which is what's required in C above, and the box doesn't exceed these dimensions, and I secure that cable within 8 inches, okay, could be less than 8 inches, but within 8 inches, then I don't need to physically secure this cable to the box itself, okay? But I also have to make sure that I extend that sheathing in through the knockout, not less than 1/4 inch, okay? That's what it's saying. And why is that important? Well, in 334.30, which is securing and supporting, it states that the non-metallic sheath cable shall be supported and secured by staples, cable ties listed and identified for securement and support, which most cable ties are, or staples, hangers, or similar fittings designed and installed so as not to damage the cable at intervals not exceeding 4.5 feet. So that's our requirement there for ongoing securement and support. And within 12 inches of every cable entry into enclosures such as outlet boxes or whatever, that type of thing. So typically you would go into the box. The code requires you to secure it to the box. We saw that in 314.17b. But it's also saying, well, this exception is saying, well, you know what? Since it's secured to the box, I'm going to let you go 12 inches. But wait a minute. You're not securing it to the box. So for movement and to mitigate potential damage as it enters the box, throw me a strap or support or a hanger or something that's, staple. Put it on there within 8 inches. And then I'll let you be less than 12 inches. And also, I don't have any concern with abrasion as it enters those boxes. And that's what we as electricians do all the time, right? We do it. Now, what about if it's a box that's bigger than those dimensions? Then the exception wouldn't apply, right? And if the exception doesn't apply, then we would secure it, follow the rules, and it would be the normal non-metallic securing rules, and that would be within 12 inches, okay? So that's what we'd have to do. Okay, so let's now move back. That was kind of our little, kind of looking at the exception. But again, the normal rule to remember is that all wiring methods should be secured to the box, unless, of course, this exception applies. And again, it's very specific to the size box that you're dealing with. Okay. All right, and lastly, we want to deal with D. Now, what is D? Now, again, we're talking about conductors. We're talking about protection of these conductors as it enters boxes, conduit bodies, and fittings. Now, D says, okay, well, what about conductors 4 AWG or larger? Because up to this point, we've really been dealing with 6 and smaller. What happens when we have conductors that are 4 AWG and larger? It says that installation shall comply with 300.4G. So that is the statement. So it says, look, if you're dealing with these conductors that enter these boxes, and we're purely dealing with conductors, even though a spattering of this has been dealing obviously with more geared towards cables. But it also has dealt with cables that get put into raceways, or it also says raceways that connect to boxes have to be connected to boxes. But it also goes on to make the statement and says, okay, look, what about these conductors that are 4 AWG or larger? Installation shall comply with 300.4G. What is it with this 300.4G? Well, let's look at it. Okay, so as an electrician or as an apprentice, you're probably pretty darn familiar with 300.4. Because 300.4 is going to talk about protection against physical damage. Now, have we defined what that is yet? No. So you're going to use your common sense. Now, look, as an electrician, I am going to make sure I install something so I mitigate the risk of physical damage, because at the end of the day, all the fingers are going to point back to me. Did I take all the precautions to make sure I protected this wiring method as I installed it? Okay, they're always going to look to me and say, well, you're the professional, you're the one that should have assumed, and so we want to make sure that we protect it. So whether or not the non-metallic sheet cable is running through board framing members, whether we're running through metal studs, whether we're running parallel with framing members or even furring strips, we have all these rules. So 300.4 is something that we're going to have another episode and spend a lot of time dissecting it, because it's an important thing to really grasp, especially for the apprentice and the journeyman as you progress to be a master. And so we're going to have an episode. But here we want to deal specifically with what we were charged with, and that was 300.4G. And that's called insulated fittings. So this one's important because remember we were talking about cables, and we were focusing on cables, even though we did dabble in the same concept of raceways, and raceways have to be secured to boxes, and we're trying to protect the conductors. Now we're dealing with, well, what happens if we are securing to raceways and tubing systems and maybe even cables and all this stuff to boxes? What happens when we got 4 AWG or larger? What do we do then? And so that's what that 314.17D is dealing with. And it sends us here. And what does it say? Well, it says where raceways contain 4 AWG or larger insulated circuit conductors, and these conductors enter a cabinet, a box, an enclosure, or a raceway, the conductors shall be protected by an identified fitting, providing a smoothly rounded insulating surface, unless the conductors are separated from the fitting or raceway by identified insulating material that is securely fastened in place. So one example may be going through a weatherhead where you have the individual conductors go through an insulated cap and they're separated, or something like that, or some type of item where it will actually has insulated material that actually securely fastens in place. It will separate these conductors that there's no way they can get abrasion. So let's talk about normal raceways. And there's one thing that you notice that is missing here. And that is, it doesn't say cables. It says raceways. Cables are not raceways. So, I get this question all the time. What about if I'm dealing with 1-aught or 4-aught SE cable entering a box in a connector? Do I have to have an insulated fitting on the end of that connector that it enters in? Absolutely, you do not. Okay? It's secured by the clamp itself that the cable connects to. So, you don't have that issue of the application. This is dealing with raceways. Now, raceways are going to cover tubing and whatnot, so but this is not an application because typically with cables, you have a listed fitting. It's going to kind of require that cable to be secured to the box and to the fitting. So not the same thing. So this is specifically dealing with raceways, okay? And it's 4 or larger. So do I have to have insulated bushings on, let's say, 10 gauges that come into a box? Absolutely not. Is it a good practice? Sure. Is it required? Absolutely not. Is there a number of them where it risks the damage of the insulation? Maybe. But this rule only deals with 4 or larger. Okay? Now, the other thing to remember is that this only applies to raceways. Again, maybe I already said that. It was redundant. All right, so I said it again. And there's an exception here. And let's kind of read it because there's a little more here. It says exception. It says where threaded hubs or bosses that integral part of a cabinet, box, enclosure, or raceway, providing a smooth, rounded, or flared entry for conductors. So I might already have an entry that's integrated as part of, let's say, the enclosure or the box or the cabinet that already has a smooth or rounded, flared throat, if you will. And if that's the case, then that is sufficient, and I don't need to have the insulated fitting. Okay, it's designed into it. Another great example would be that is a hub that's on top of a meter, or let's say a hub that's going into a top installation on a panel on an exterior, and it comes into the threaded hub. If that's the case, then it's designed that it's not going to need that additional insulated fitting, and it's probably no way you could put one on the end of it because it just simply dumps right into the enclosure. And usually it has a beveled edge or a curved edge, so the sharp edges are rolled over. Not a problem for that. So that's what that exception's talking about. And then it says, conduit bushings constructed wholly of insulating materials shall not be used to secure a fitting or raceway. The insulating fitting or insulating material shall have a temperature rating not less than the insulating temperature rating of the installed conductors. You don't want to use an insulating fitting, a bushing, if you will, that's rated for 75 if your conductor's insulation is rated for 90 or 60 if you're using a 90. So you just need to make sure that the fittings, and I think that pretty much takes care of itself now in the industry, but that's just a reminder that you need to do that. Okay? Also, again, it reminds you that, let's say I'm bringing a rigid to an enclosure, and I'm using the method where I have a lock nut on the outside and a lock nut on the inside. I can't, by virtue of removing the lock nut on the inside, by using some insulating bushing to do that. Okay? You can't do that. Okay? You have to have your own separate type of fitting for securing of that raceway. Okay? The bushing is simply there to prevent abrasion. Now, if they happen to make a product that does both and there's a listing for it, okay. But in general, remember that if I'm bringing a conduit to an enclosure, that I'm going to have a mechanical requirement to secure it, and that's when I would use a lock nut. Okay, well, that lock nut, that type of thing for that application. Now, remember, we have a lot of bonding requirements that you have to be aware of in 250.92 for service applications for a more assured bonding. So when I make mention to lock nut, that's just a certain type of fitting, but there might be other types that you have to use for securing that also meets a bonding requirement. So don't get overly drawn out. You need to watch our bonding and grounding videos to get that. We're just talking about, look, a little old insulating bushing cannot be mechanically securing that raceway to the box. Okay, you got to have some other means. This is just there to protect those conductors as they enter from sharp edges as they enter the box. That's all that's talking about. Okay. All right. While we're here, let's go on and talk about flush-mounted installations. I see a lot of these done wrong as well. And There's a lot of products on the market, extension sleeves that you can put in, non-metallic, to extend the box out. But more often than not, I see people violating this all the time, especially when they're cutting them into boxes and cabinets, wood cabinets and things like that, that they really don't think about this. And, you know, if you've ever had a short, you know that energy can cause things that are combustible to potentially start a fire. And remember, we're talking about not probables. We're talking about the minimum safety standard. We have to protect against something that could happen. So 314.20 deals with flush-mounted installations. What is a flush-mounted installation? Well, that box comes right up to the surface of that finished surface so that I'm mounting a flush fixture or whatever on it. It's going to mount on the surface flush. Okay? All right? So it's for installations within a surface. And here we're going to talk about the aspects of in the surface, whether it's wood or not, combustible material or non-combustible material, and what you have to do here in order to have a flush type cover to be able to mount onto it. I'll give you an example. Most boxes that go in the wall with receptacles that go in it have a cover on it. That is an example of a flush mount application. Now it says installations within or behind a surface of concrete, tile, gypsum, which is drywall, plaster, or other non-combustible material, including boxes employing a flush-type cover or faceplate, shall be made so that the front edge of the box, the front edge of the box, plaster ring, extension ring, or listed extender will not be set back of the finished surface more than 1/4 of an inch. Okay. Now, 1/4 of an inch is not a lot. So, if I have a box and I put it in the wall, and I'm going to not use so let's say it's a 4-inch square box, but I'm going to put a plaster ring on it, and it's a raised plaster ring, and I'm going to extend it up because I'm going to have now a surface on it of, let's say, gypsum board, drywall. I have to make sure that I design that enough that I use the right plaster ring that's going to extend that lip out so that it's flush with the wall surface. Or I have to make sure that it doesn't go back more than 1/4 of an inch. So 1/4 of an inch is my de facto limitation. If I have a normal nail-up box, I'm going to nail those boxes. Usually a nail-up plastic box have that little notches on it to tell you how far. Kind of help you guide yourself. But I'm just saying, when you teach your helpers, they don't all of a sudden know those notches are there. I trust me. It's the little things that we sometimes don't teach. And so what happens is they just nail them things up, and then you get screwed because you have to go in and get these extensions and put them in. They're not expensive, but you got to do them. The other thing to keep in mind is a lot of times you have all intended purposes to do this right for the gypsum board, and then all of a sudden they put a cabinet in. And they put a cabinet, and now your box is recessed further back in the cabinet because it planned on being a finished wall, and now they put a cabinet or something in its way, and then now you're kind of screwed. So you got to think about these inserts. And they do make them. They are available. And they just simply slide inside the box, and they offer that protection from the live parts and where the arcing typically can take place. And the last thing you want is an arc to get in there in that space between the wall cavity. Okay, you don't want that to happen. And for an easier explanation, have you ever seen those shows where they start a fire by the little embers and they blow on it? Well, think about this. If I have a box and I don't maintain the gaps right, we're not talking energy code, but we have these gaps and they don't do them right, we're going to see the gap requirement in a second. But let's say that's one of the biggest violations of the code people don't think about. Now you have can create, if you have a loose envelope in the building, you could have what's called a suction point. And now let's say you have an arc and something ignites and these embers get in there, and now you have this vacuum that's taking place, or air movement. Again, you can't guarantee it's not. Now you have these embers that might sit on something combustible, and now you have the air feeding these embers, and you could have a smoldering fire take place. I mean, it could happen. It literally could happen. Now you're saying, yeah, but I also could win the lottery. I understand. But I have a greater chance of this happening, for me anyway, than win the lottery because I don't buy lottery tickets. But this is the case. It could happen. So how do we mitigate the risk? Remember, it's a minimum standard. The probability is there. So making sure that I don't extend it more than 1/4 of an inch back is going to help do that. Now, what happens if I do that and now I'm doing this, let's say, in a wood or some other combustible surface? Now, we have a list of what's considered non-combustible. I mean, they gave us that. Plaster, gypsum, concrete, or other non-combustible, and we're going to let the manufacturer, whatever that product is, to determine whether it's non-combustible or not, so the inspector might ask for documentation. But those given ones, gypsum, drywall, sheetrock, whatever, we know is a non-combustible, so we can set back no more than 1/4 inch. But now, if we're putting it in a surface that is wood or some other combustible type of material, then the same thing applies for these boxes, plaster rings, extension rings, or other listed extender. Shall extend to the finished surface or project therefrom. So it can either come right up to the surface or stick past the surface. Now, if it sticks past the surface, it kind of defeats the point on a flush mount, even though some of the face plates are concaved, so it might give you a little bit of leeway there. But the reality is, it has to be flush. There is no level of extend back. Not even a 1/16 of an inch back. It has to be flush. Okay? So, that's the issue with combustible material and whatnot. So, these are the two things that you really need to take into account when you're dealing with application. You really need to follow whether it's combustible. Now, most of us deal in drywall, residential, sheetrock, those type of things. I can go back 1/4 inch. Otherwise, I'm going to need those extenders to bring it out flush. Okay, they're cheap. They're available by many manufacturers to do that. Okay, but you got to do it. I actually saw a post online the other day where everybody was so focused on the fact that the box was back farther and the receptacle was having to stick out, so they needed longer 632 screws to be able to put the device in. But nobody addressed the fact that that box was sitting back about 1 inch into the wall. And so I mentioned, well, you need an extender because it's sitting back too far. But everybody was so focused on, hey man, what kind of things do I get in order to put onto the screws so that I can hold it firmly away from the box? And I'm like, that's the smallest part of your worry, because most of the time you've got those little arms or cleats that are on the actual strap that goes against the finished surface, provided they cut the box out right. And so you just need longer 632s. But the reality is, I still need to protect that portion of the side where that device is being wired. And so that's why this is so important. Again, I see it violated all the freaking time. So we have to make sure we do that. Okay? Now, the last one we're going to look at in this episode is 314.21. So now we're taking care of all that. Well, what happens if I have a non-combustible surface, like gypsum and tile or plaster, and whoever's doing it the gap is too big around it. It's too wide. Now, we're already getting this allowance to go back 1/4 inch. Well, if we don't make sure it's tight around the box, then we're defeating that, because then it's allowing it to get in and behind that non-combustible material where it could come in contact with combustible material like the framing members. So, what do we got to do here? So it says, look, repairing non-combustible surfaces. It says non-combustible surfaces. Again, we're in 314.21 if you're following along. It says non-combustible surfaces that are broken or incomplete around boxes employing a flush type cover or faceplate. Okay, so again, for you and me as an electrician, it's those boxes that go into the wall that you're going to put a device in or a switch in, and you're going to put a cover plate on it. It says shall be repaired so that there will be no gaps or open spaces greater than 1/8 of an inch at the edge of the box. All around the edges of the box. So it has to be repaired. Now, I understand it. You're the electrician. And you put it in and you leave it up to the sheetrockers. Okay? And the sheetrockers go in there, or the plaster guys go in there, and they're going to cut these openings. Now, advice. Push your wire back of that box as firmly as you can. Now, you might get lazy and want it to look neat and have the wires bent so you can see them from the edge of the box. Dude, trust me. these guys, and in no disrespect to them, but they're all about the number of openings and how quick they put this drywall up or whatever up. They're going to whip this stuff into place, and they're going to use things like spiral cut saws, and they do make one specifically that's designed to cut boxes but won't cut wires. I hear you, but I routinely see these wires cut because the electrician didn't push them back far enough. Push them back. They're going to go in there and they're going to zip this thing around. Now, a lot of times they'll zip it from the outside, and so they can get a little squirrely. And what happens is that sometimes it'll break the drywall around it or gypsum around it or tile, and so you end up with a larger gap. That has to be replaced. So you think that I come around, that maybe the inspector won't see it because by the time it gets to the final, that it's going to have the cover plate on it. Okay? I wouldn't rely on that. And again, you have to sleep at night, and you know what your code says. And yes, it sucks that another trade screwed with your stuff. Okay, I get it. But you have to fix this. Now, one advice that I've done in the past is that I will actually go to the owner or contractor or the general contractor, whatever, and say, look, you need to patch around these boxes. Okay? Or I can do it myself with some sheetrock mud. And what I do is I'll go around it, and I'll actually go and use a small sheetrock knife. And when I dig into it, I'm actually pulling towards the box. So I'm letting the box act as a scrape, and I'm scraping it towards the box, and I'm just doing it all around all the edges of it. So I'm building up that bead around the edge, and then I smooth it down with a nice smooth stroke of my knife, my drywall knife. I don't go from the box out. Okay, because I don't want to get any in the box. I go the other way. I go from the drywall towards the box, and I only do it to try to put it on that last eighth of an inch, anything that's greater than eighth of an inch. Because I'm really trying to, because my cover is really going to cover anything else. It's unfortunate that we have to do that, but it is what it is. So if it's not a real big gap, but it is over an eighth of an inch, then usually some drywall mud will get you through that dilemma. If it's any more than that, then obviously you can use drywall tape and mud and try to do that as well. Okay, because really you're just trying to close the gap. Now, whether that's copacetic to the building inspector or whatever, hey, dude, I'm just the electrician and I'm trying to meet what my code says, and that says close the gap. That's all I'm trying to do. All right, I'll let them work out those details. Again, if you're a building guy and you're listening, you're going, that's not right. Well, then you need to go listen to a building code forum. This ain't what it is. This is electrical. And I'm trying to move on, okay? All right, so there you go. That's all today's episode. We kind of covered the gist of the box of conductors entering boxes, and we even dabbled into around the boxes. The next thing that we're gonna deal with is we're going to do a little episode on supporting boxes and all the concepts of how you support the boxes. And that's going to be in 314.23. And that's going to be probably the last step before we start moving into dealing with boxes and pulls and U-pulls, and we might also dabble in, and when we're dealing in support, we're actually going to cover a lot, but we might also deal in 314.24 with is the depth of the boxes. If I can cover all that in an hour, I'll try to do that. But then really what we're going to do is we're going to try to move on to something else a little bit more involved in that. Okay, but we'll cover depth of boxes and all that kind of goodies stuff. So again, I don't know how many episodes we need to cover all this topic, but we'll try to cover as much as we can. All right, my friends, again, it's an hour long. I know people say I should cut these down to 15 minutes, but I just can't help it. Again, one tip is you can listen to it to a certain point, write down the time you stop listening, and then come back and then speed forward on the player to that time and pick up from there if you want. That's one way to do it. I just can't change my method because I got so much to say and so little time to do it. So it is what it is. So until next time, folks, visit our website, masterthenec.com. Go to our YouTube channels, our Facebook, our LinkedIn, or all those channels. Chime in, join, follow, do whatever you do. On the Master the NEC website, up at the very top, you'll see links, buttons to all of those different forums, and share them with other people. Again, these cost you nothing. Let us know that you like the podcast, because some people are very visual learners, And there's a lot of people that seem to be giving us a lot of feedback. They simply love our podcasts for some reason. They like listening to them on job sites. So I'm going to keep doing them. And they're easier for me to do. Okay, I don't have to look pretty and stand up in a camera and have all that extra editing because I'm just trying to get as much out. And again, I realize that people are working and they can listen to my podcasts while they work. Gives them something to listen to. So, be honest with you, I used to listen to podcasts before I went to bed on my phone, right by the bed. I just put it on, and sure enough, I am more than sure that if you need something to put you to sleep, my podcast will put you to sleep. Anything code related puts a lot of people to sleep. Anyway, till next time, folks, stay safe and God bless.
Every day, the future's getting closer. Every day, the future's looking bright.